On the evening of January 27, 1986, the night before the Space Shuttle Challenger was due to launch from Kennedy Space Center in Florida, the engineers who built its rocket boosters told NASA that the cold would break the seals. Their own managers overruled them before morning. 73 seconds after liftoff, Challenger came apart over the Atlantic. All 7 people aboard were killed. This is how that decision got made. The Space Shuttle's solid rocket boosters were not single tubes of steel. They were built in large segments, shipped by rail and joined together at the launch pad into towering stacks. Each seam between segments, called a field joint, was sealed by 2 rubber O-rings meant to trap explosive combustion gases inside the casing. Morton Thiokol of Brigham City, Utah, held the NASA contract to design, build, and test the boosters. As early as 1981, Thiokol engineers began finding trouble after recovering flown boosters from the ocean. Inspectors found scorched O-rings and hot gas escaping past the seal before it fully closed. The damage was not constant from flight to flight. It grew noticeably worse in cold weather. On January 24, 1985, Mission 51C launched at about 53 degrees. When technicians opened the recovered boosters, they found the worst erosion and blowby of any flight to that date. That July, Thiokol engineer Roger Boisjoly wrote to his vice president of engineering, warning that if the joint problem went unfixed, the result could be a catastrophe of the highest order, loss of human life. Thiokol formed an O-ring task force. By January 1986, the redesigned seal Boisjoly wanted was still unfinished, existing only on paper. Mission 51L carried 7 people: Commander Francis Dick Scobie, pilot Michael J. Smith, mission specialists Judith Resnick, Edison Monazuka and Ronald McNair, and payload specialists Gregory Jarvis and Krista McAuliffe. From more than 11,000 applicants, NASA had chosen McAuliffe to teach 2 lessons from orbit, broadcast down to classrooms across the country. By January 1986, this was no ordinary flight to slip or delay quietly. Television networks, school districts, and a president who would mention it in a State of the Union address were all watching the calendar. On the evening of January 27, 1986, NASA convened an emergency teleconference linking Thiokol engineers in Utah with officials at Marshall Space Flight Center in Alabama and Kennedy Space Center in Florida. Forecast overnight freeze had raised alarm only hours before the scheduled launch of Challenger. Thiokol's vice president of engineering, Robert Lund, laid out the company's recommendation on presentation charts read aloud over the phone lines. He told NASA the shuttle should not launch below 53 degrees Fahrenheit. Anything colder fell outside the booster's tested range, and Thiokol's engineering staff stood behind that limit unanimously. Roger Boisjoly and Arnold Thompson pressed the point, warning that colder rubber would seal more slowly and less reliably. They pointed to 51C, where the worst erosion yet had followed a 53-degree launch. George Hardy, Marshall's Deputy Director of Science and Engineering, responded that he was appalled by a recommendation not to launch. Larry Mulloy, NASA's Solid Rocket Booster Project Manager, challenged the data directly. "My God, Thiokol, when do you want me to launch? Next April?" The forecast that night called for a low near 18 degrees. Thiokol asked for 5 minutes off the line. The caucus ran roughly 30. Behind closed doors, without NASA listening, Thiokol's senior managers reconsidered their own engineers' unanimous recommendation. Senior Vice President Gerald Mason turned to Robert Lund and told him to take off his engineering hat and put on his management hat. Boisjoly and Thompson kept objecting, repeating that cold O-rings could not be trusted to seal. The room had already shifted around them. Only the 4 managers present were polled on the final vote. The engineers who had spent hours raising the alarm were not. Thiokol reversed its recommendation and backed flying as scheduled. NASA accepted the reversal without recording any dissent on the call. Joe Kilminster signed the formal launch recommendation in Utah and sent it to NASA by fax. Allan McDonald, Thiokol's senior representative at Kennedy Space Center, refused to sign it and warned NASA officials he did not want to be the one explaining that decision to a board of inquiry. Ice inspection teams walked the pad before dawn on January 28, 1986, and found icicles up to a foot long hanging from the launch pad structure. 2 hours behind schedule, at 11:38 in the morning, NASA decided the vehicle was clear to fly. At liftoff, the air temperature was 36 degrees Fahrenheit, the coldest launch in the program's history, and the right solid rocket booster, shaded through the night, was colder still. None of them had been told that Morton Thiokol engineers, builders of the booster rockets, had spent the previous night arguing forcefully against this exact launch. Challenger lifted off from Kennedy Space Center. Cameras caught what no one at the Cape could see. At the instant of liftoff, a puff of dark smoke curled from the right booster's aft fuel joint. Analysts later matched that puff to hot gas breaching the very seal the engineers had warned could not hold in the cold. For nearly a minute, Challenger seemed to fly clean. Melted slag from the breach had plugged the gap, sealing the joint by accident rather than by design. Around 59 seconds into the climb, wind shear flexed the booster and reopened the joint, letting flame burn through toward the external fuel tank. At 73 seconds, the tank ruptured. Escaping propellant ignited, and Challenger broke apart roughly 46,000 feet above the Atlantic. All 7 crew members were killed. The crew cabin tore free, largely intact, and fell for more than 2 minutes before striking the ocean. The rupture had begun at the same aft fuel joint, on the same right booster that the engineers had named the night before. In the accident's wake, NASA grounded the entire shuttle fleet for nearly 3 years. 6 days after the disaster, President Reagan formed an independent commission chaired by former Secretary of State William Rogers. Its members included Neil Armstrong, Sally Ride, and the physicist Richard Feynman. At a televised hearing on February 11th, Feynman clamped a piece of O-ring material in a C-clamp, dropped it into a glass of ice water. Pulled out minutes later, the rubber stayed compressed instead of springing back. The Rogers Commission reported in June 1986 that the accident was caused by a failed O-ring in the right booster's aft fuel joint, a failure made worse by the cold, and it called NASA's decision-making seriously flawed. That October, the House Committee on Science and Technology found that Thiokol's own management had overridden its engineers' unanimous recommendation not to launch. Thiokol reduced Allan McDonald's rank. He was later brought back, and Congress publicly praised him for refusing to sign. Roger Boisjoly left the company after being ostracized by colleagues and unassigned from spacework. He spent decades afterward speaking publicly about the warnings he had raised, and became a standard case study in engineering ethics. The fleet did not fly again until Discovery lifted off in September 1988. The engineers were not guessing. They had the data. They put the warning in writing months before. They said it again on the record the night before the launch. What burned through at 73 seconds was the seal they had named. What failed the night before was the decision to set their judgment aside. That was this story here on Errata. If you enjoy forgotten history told accuracy first, subscribe to the channel and give this video a like, and we will keep bringing the past back to light.